Melanie Swan is a founder at the Institute for Blockchain Studies. She has a background in finance, computer science, medicine, art, and other topics, and she joined Software Engineering Daily to discuss the blockchain's application to all of these areas. Melanie, welcome to Software Engineering Daily.
Hi, Jeff. Thanks for having me.
What is the blockchain?
So blockchains are the distributed ledger technology underlying Bitcoin and other cryptocurrencies, and more broadly, a mechanism for updating truth states in distributed network computing, producing consensus trust, and serving as a new form of general computational substrate.
One way to look at blockchain is as a solution to the Byzantine generals problem. What is the Byzantine generals problem?
So the Byzantine generals problem comes quite literally from Byzantium in the year 555, when the Byzantine Empire was at its height of conquering different territories around the Mediterranean. And the issue is communication. How do you do communication in a distributed network? And in this case, amongst Byzantine generals, where you don't know which might be defecting or otherwise impaired as a node. So the Byzantine consensus problem is how do you do trustable communication in a distributed network? And that is exactly what we're trying to do in Bitcoin, or the blockchain, which is a distributed computing network. We would like to have trustable truth state updating across the network.
And I think Byzantine generals is iconic of a larger class of problems in distributed systems. But what is the double spending problem?
Okay, so there are really two key problems that Bitcoin starts to get around. And the first and most straightforward is the double spend problem, and then secondly is the Byzantine consensus problem. So the double spend problem is like any digital asset. When I send you an email with a photo or document attachment, you can make a digital copy of that attachment as many times as you like. And that's fine maybe for an image or a document, but that's not good with money. We want money that's only spent once. And so we've been trying in the computing world for decades to come up with a good digital cash solution, but there hasn't really been one until blockchains. And so what blockchains do is set up a distributed network where independent parties, miners, confirm and move the balance in a wallet address between my wallet and your wallet, for example, if we're doing a transaction, and only allow that money to be spent once. And so that, because the blockchain is a distributed network with independent parties confirming and validating the transactions, that gets around the double spend problem. So that's been really an a step forward that blockchains have been able to do. Now, the other problem, the Byzantine agreement, is a more extensive kind of problem. It's a little bit more detailed, and there have also been proposed solutions on this for years. And the first ones were from Leslie Lamport at Microsoft, proposing Paxos, and that's a state machine replication algorithm that synchronously updates a network. And Google's Chubby algorithm serves strongly consistent files and also draws on that first level of Byzantine agreement protocol. The issue is that those protocols update all network nodes synchronously. And in the bigger, to be really truly world scale, large networks, in the case of future uses of blockchain technology, we can't depend on synchronous network updates. It really needs to be asynchronous. And so therefore, that's when blockchain and Nakamoto starts to come in as proposing a solution for Byzantine agreement that's asynchronous. And so this is a proof of work algorithm, which is by which the blockchain currently runs, but it's expensive and high latency. And also the proof of stake consensus derivation algorithm has been proposed and is in use, but has some other potential risks. And so this proof of work Nakamoto consensus is, we know it's a Sybil attack resistant compromise for decentralized consensus at the moment, but it's probably not the final solution for truly world-scale distributed network fault-tolerant security because it's just too expensive, it has poor scalability and high latency. And so then other consensus protocols have been proposed to the Byzantine agreement problem from Pebble and Ripple and Stellar and even
Absolutely.
prediction markets.
So we'll get into that. But just to put a reinforcement around that, so the double spending problem is essentially the base case example of all the problems that can occur in a multi-user financial network without a central institution. Do you agree that this is true?
The key thing that Bitcoin resolves is the double spend problem. I would agree with that.
Okay. And so let's start by discussing the blockchain in its most familiar form, which is Bitcoin.
Yes.
And you touched on how Bitcoin uses the blockchain, but could you go into a little more detail?
Let's see. So let's distinguish between Bitcoin and the blockchain. So the blockchain, it's sort of like, if we think about, a good analogy is SMTP as the protocol by which email operates, and it runs over on the internet. So similarly, blockchain software is the underlying protocol layers that allow digital transactions to happen. And then Bitcoin is one particular application like email. It's a cryptocurrency, a digital cash application. And so we should think of blockchain as the underlying plumbing, the software, and Bitcoin and cryptocurrencies as an application layer thing. So, and then the blockchain itself, so it's called a blockchain because that refers to when Bitcoin transactions are submitted, the software automatically gathers them into blocks of, say, 1,000 transactions at a time every 10 minutes. And these transactions are posted together in a block. And then blocks are confirmed by miners. And then the next block in the first line always calls the address of the previous block. So that creates a permanent sequential record. And that's why it's called a blockchain.
What are the features that every blockchain has?
Generally, blockchains have a certain structure.
Beyond Bitcoin, I should specify for the listeners.
Oh, I see.
So this is like generalized to things that are true for a blockchain within Bitcoin, but also just true as with blockchain as a fundamental breakthrough.
Yes, and while realizing that there are now public blockchains, private blockchains, blockchain itself as a computational concept is evolving. But the general structure of a blockchain is that it's a software, these transactions are packaged into blocks, and then a random number is created specific to the block, and then metadata about that random number is published to the web, and these are its cryptographic parameters, its difficulty, a service string, a nonce, which is a 32-bit number, and a counter. And these are the cryptographic parameters of that block. And then anyone running mining software performs computations and submits cryptographic guesses as to the specific nonce of this particular block. And it's really a trial and error computational guessing process. And then the mining machine with the correct guess wins the right to actually record the transactions and receives the block rewards or the transaction fee for doing so.
Would you say that the blockchain is a database that is distributed throughout the world?
Yes, definitely. So one way that we can be thinking of blockchains is that a blockchain is like a giant interactive Google Doc spreadsheet that anyone worldwide can view on demand, where independent administrators or miners continually verify and update the ledger to confirm that each transaction is valid.
So if we all have a giant ledger, we all have to have a copy of this, and these transactions are getting added to it over time, doesn't this ledger get too big for everybody in the network to hold on to a copy of it?
Yes. So right now, so it is Bitcoin, and these cryptocurrencies are open source software. So that means that anybody can go to GitHub and download the software on a variety of different platforms. And there are currently about 7,000 global nodes running the full Bitcoin D or Bitcoin daemon node. And you can go to bitnodes.io and look up which nodes these are anytime. And so, the nodes running the full Bitcoin transaction ledger since the very beginning It's currently about 25 or probably about 30 gigabytes to run the whole transaction ledger. But there are a number of software applications than an ecosystem such that you don't really need to run the whole transaction ledger, the whole history of all transactions, to actually find out updated address balances and valid addresses and things like that. So companies like Chain.com and other blockchain software ecosystem companies have provided different kinds of APIs to the information on the full blockchain daemon, but for much more practical use in applications and day-to-day software wallet operations. So, for example, my Mycelium wallet on my cell phone certainly doesn't have the whole is not running the whole full Bitcoin D node, but it does have an ability to call information to confirm that my address balance is valid when I'd like to buy a coffee, for example.
Could you describe mining in a bit more detail and define the word nonce?
Nonce. So yeah, a nonce is a cryptographic guess, and it's a 32-bit character. And so what happens in mining is that, and the Bitcoin network uses proof of work mining. So this is the idea of putting in computational work to try to earn a reward and to deter malicious players. So since you have to put in work to possibly win the blockchain rewards, if you're a malicious agent, it's not worth your while. And so that's why Bitcoin mining can be expensive and use a lot of electricity, is to deter malicious players. And how it works is you just download the mining software package, and this package will track what the latest block parameters are and run cryptographic guesses or hashes per second. And so your average, right now, the Bitcoin computing network is actually the biggest supercomputer we've ever had. It runs on the order of 380 petahashes per second, as opposed to your average laptop, which would be about 1 petahash per second. And so out of nowhere in the last 2 years, the Bitcoin network has come and become the world's biggest supercomputer. Now, so in mining, there'll be millions of guesses then per second for this particular nonce or 32-bit character for this particular block and the block rewards. And so machines worldwide just run trial and error guesses to try to obtain that result or to try to guess that nonce. And that keeps the system secure because it's completely unpredictable and unknowable what that nonce will be. It's determined by software, and then the winning machine, the winning guess, then gets the right to the block rewards.
So as you have defined, blockchain in terms of Bitcoin is this distributed ledger that everybody has a copy of, and miners are continually mining, which means that they are attempting to come to a consensus on the status of the ledger, and the incentive that they have to come to consensus on the status of that ledger is that they will receive more Bitcoin if they work to verify that they have the correct view into the world and that everybody else in the network has the correct view into the world. So it's essentially the generalized idea of the blockchain is everybody is incentivized to work towards agreeing on a source of truth. Is that accurate?
That's fairly accurate, yes. But the confirmation happens, the sequence is a little bit different. So what happens is whoever wins the block reward and records the actual transaction, then all of the other nodes in the system come and confirm over time the accuracy of those transactions and do the same confirmation. Oh, did this wallet balance have this amount? And yes, it was transferred to this other wallet address. And so the confirmations come in time after the moment that the block is actually recorded. And one thing that's interesting is that so eventually the consensus comes as all the other nodes confirm the new truth state of the system, and that's asynchronous. And what's interesting is that the security is a geometric and nonlinear progression, in that by the time you have another machine and a second and third, or a third and fourth and so on, as you have additional nodes confirming the truth state in the distributed network, it becomes geometrically harder to undo the transaction. And so that's the higher level of security that's conferred by a consensus mechanism like a blockchain.
So I think a good analogy I've heard to this is that in a system like Bitcoin, the most recent past is like the slushy layer on some sort of Arctic plane, and it's slushy, it's mutable, but the lower layers of the deeper you go back into history, the more it is an icy, rigid crust that cannot be changed. So the recent history, more mutable. The further you go back, it gets exponentially, or geometrically, I'm not sure what the right word is, more difficult.
Yeah, so certainly, but however, even the mushy first confirmation is also already somewhat icy, but it does get icier.
Right. Okay, so how do we begin to decouple the idea of blockchain from the idea of mining?
Why? What would be the purpose, or why?
Oh, well, so as I understand, something like Ripple, for example, or maybe I misunderstand, but Ripple doesn't need mining. It has a different sort of consensus protocol. So what I took away from that is that the idea of the blockchain is actually not closely coupled with the idea of mining, but maybe I'm mistaken.
Yeah, so blockchains are distributed ledger technology. It's just it's sort of a general computing structure for doing any kind of tracking and transfer. And how they do that is with consensus mechanisms, and mining is one form of a consensus mechanism. And so, yes, so then in the case of Ripple or Stellar or other kinds of operations, the other kinds of blockchain operations may use other kinds of consensus mechanisms.
Sure. Okay. So maybe we could contrast some of those. Could you start by contrasting Bitcoin's blockchain strategy with Ripple's?
Sure. So Ripple is basically a private chain, and it's not mined. So how consensus works is that the different network nodes vote on the veracity of transactions in order to update the ledger. And they have a complicated process of 50% of the nodes need to confirm the veracity, and then sometimes 80%. So it's a little bit of a complicated protocol, but basically all of the participating nodes vote on the veracity of incoming transactions. And so so that counters the problem of a proof of work mining situation, which is very expensive.
And Stellar is similar to that, but could we discuss Ethereum? Are you familiar with Ethereum?
Sure. Yeah, definitely. So just to mention, so Stellar is a fork off the Ripple code base, and Stellar is quite similar. They have a two-tier system where, first of all, they have a new idea called quorum slicing, which is that any new node joining a network, any new node can freely join a network, as opposed to the Ripple model, for example. So in Stellar, a new node joins the network and looks at 3 or 4 local peers, and initially assumes they're trustworthy until proven otherwise. And so this is a quorum slice. You don't need to know the whole network, but you establish a local slice that you trust yourself. And then that's how you get your network updates, your updated truth states. And then that way, if there is a malicious node or a malfunctioning node, a befouled node, as they're called, then you have your other truth nodes. And so any one node can continually stay updated as to the truth state of the network. So in the Stellar model, there's first of all the quorum slice, that a new node finds its own mini trust network. And then the second portion of that is similar to Ripple. It has a node voting on the quality of the truth state updates as the means by which the truth state updating actually occurs.
So that sounds. Oh, if you were done discussing, I
yes.
actually would like to discuss Ripple versus Stellar a little more, because now that you've articulated some differences, that actually sounds pretty relevant.
Okay, maybe, but maybe we could look.
If you want to just jump forward
more broadly. Yeah, that's fine. Sure. And then because there are different use cases, so Stellar is contemplated for use in a variety of different kinds of distributed network computing, as opposed to Ripple, which is designed really for bank interbank usage. So usage within Chase Bank and all its nodes, for example, and they would like Chase Bank would like a private blockchain network to do its internal confirmations that where Wells Fargo doesn't see it, for example. And so so Ripple is focusing on the bank clearing and settlement sector, bringing bank transfers down from 3 days to much more immediate transfers. And Stellar is focusing on a number of different kinds of industries and different kinds of applications. And so therefore the consensus mechanism used by both could be different. Then another aspect is this general forking, and what is Litecoin, Darkcoin, Namecoin, Bitcoin, etc. And so what happens is all of these coin projects are open source software, and so that's really great because it allows rapid iteration. And so if you, as a developer, look at the blockchain and you say, "Hey, that's really great," and I'd like to add this other new functionality and new features. And so you download the Bitcoin code base, and which is a fork, and then you fork it over to do a new code base with your additional functionality. And so that's what happens with many cryptocurrencies. They most often have started as a fork from the Bitcoin blockchain software repository, and then added additional features. That's true for Litecoin. And then Namecoin, for example, is a non-currency implementation of Bitcoin, initially Bitcoin code, for the purpose of decentralized DNS registration. And so the subsequent forks and applications don't need to necessarily be currency related also. And so that's why Ripple is a fork. Stellar is a fork of the Ripple code base. Litecoin is a fork of the Bitcoin code base, and then and so there are ecologies of these crypto software projects. Ethereum is a separate blockchain. It is also mined. It has its own token, and it was just released on July 30th, a week ago, and already there are over 61,000 transactions, 61,000 blocks on the chain. You can look at the etherchain.org is the block explorer for it. And in the case of Ethereum, its consensus mechanism is currently a proof of work consensus mechanism, just like Bitcoin, but it's envisioned that it will eventually shift when the platform is more mature. It'll shift to a proof of stake consensus mechanism.
Could you describe the difference between those two things?
Sure. So
proof of work versus proof of stake.
Yeah, so proof of work and proof of stake are the two primary blockchain consensus mechanisms, consensus protocols. And proof of work is the actual performance of a computation doing work to demonstrate that you are a bona fide good player agent participating in this network. Proof of stake is an ownership stake. So because I own this server here that I put on the mining network, that is thought to confer the same trustability. I'm providing a proof of stake. So both are cases of a proof of something, a proof of some sort of ability or capacity to participate in this network. And proof of work, I'm doing some work, and proof of stake, I'm providing an actual asset.
Right. So that was a very excellent, crisp explanation. So I would eventually like to get into some of the higher level economic implications of blockchain technology that you write about so much. But first, I would like to talk a little bit about something something I see as an interesting societal aspect. So Vitalik Buterin, the creator of Ethereum, he strikes me as this. Strikes me as an excellent leader, which I find interesting because there's a tension in the decentralization community between, do we need leaders or do we not need leaders? Because, the whole idea of decentralization is you don't need centralized institutions, and the idea of a leader seems like a centralized component. Do you feel that there's this tension between having a leader and wanting to decentralize everything?
Well, I guess I see an facilitator. There are people that do things, and they could do it in a peer basis. They could do it in a facilitative basis, and a leadership basis. Is the leader more collaborative, or is the leader more dictatorial? So leaders themselves are not anathema, I would say. And one of the great things about the crypto citizen sensibility is rethinking relationships with authority in every venue, and including economics and politics. And so so we would be, the crypto citizen sensibility examines leaders to be displaying and qualities that are more facilitative and collaborative rather than dictatorial. And I think Vitalik and nearly everybody in the cryptocurrency movement, or I haven't analyzed necessarily, but the general esprit or culture is one of collaboration.
Your book is called Blockchain: Blueprint for a New Economy.
Mm-hmm.
I love the ambitious promise of the title. So let's talk about some of the applications of the blockchain. And we'll begin with the straightforward domain, which is finance. And we'll get progressively more interesting. But are old and major financial institutions adopting the blockchain?
Yes, and in fact, what's very interesting, it's sort of like the internet. It's really for everybody. It's for legal and illegal purposes. It's for traditional, institutional, corporate, government users, and for entrepreneurial users. It's really for everyone. And so, blockchain applications are, number one, it's a better it's a better horse. It's a better way to remake our existing world, where some of the biggest applications in banking and financial services are that any kind of transfer has been taking 3 days. And that's true for securities trading settlement, and that's true for bank transfers. And why in this day and age would it need to take 3 days to transfer a digital asset on a ledger? And so, number one, blockchain applications are a better horse. They improve the way we do things now. But the big promise is that blockchains are also a car, which is a revolutionary new way of doing things. And it's really a moment in getting us to a larger scale form of computational infrastructure to really get into the big data era. For example, with million-person genome file health data commons, for immediate worldwide cash transfers, for communities that are global and local at the same time. And so with the car, we don't even know what the potential future applications could be, but blockchain technology is extensible for not just rebuilding our world better, but for making a new world too.
I spent some time in finance, and something that was difficult for me is I felt that there was a mistaken assumption of this efficient market hypothesis thing where you can't make new value in the world. The amount of value in the world is fixed based on like thermodynamic laws or something. And so I'm curious, in your experiences, in your discussions, do the major financial institutions understand that if you make a core fundamental invention breakthrough like blockchain is, more value appears in the world? Or is the way that they look at it just, oh no, value is disappearing from our coffers and going towards some blockchain institution? Like, how do they see it?
Well, I think the nice thing is that blockchain accommodates both views. Either the pie is fixed and we're fighting over it, or the pie keeps growing. And so some people really get it, like Blythe Masters, formerly at JP Morgan and now leading a digital asset group, understands the pie is bigger. Frame, and many executives in banking and finance, I think, understand they're very much motivated by a fear of our pie is shrinking, and how do we need to move to get out of that? And so we need to start looking at blockchain technology as even just the next new software. You don't need to buy into any of the ideology of blockchains. It's really just an improved software play.
I see. So it doesn't sound like there's any like total zero sum anti-Bitcoin strategy, because there's no real route to implementing that strategy.
Yeah. So I guess the most conservative position would be, we really need to see that any new software technology proven before we start to implement it. Maybe we hire some outsourcers in our value chain, and they take some of the blockchain technology risk. But there's really there can be conservative implementations as well, that are still an exploratory stance towards blockchains.
Right. Conservative, but not bearish.
Yeah.
Talk about the blockchain applications to commerce, such as OpenBazaar.
Oh, sure. So what's interesting is that the blockchain ecosystem is evolving quite specifically into different sectors, different industry sectors. And in the case of exchange or decentralized marketplaces, there are a couple of known examples, OpenBazaar and Bitmarkets. And these are essentially the Craigslist, a decentralized version of Craigslist. And so any community could implement an application like an exchange application like OpenBazaar. And that could be for hospital equipment inventory in our city, for example, or it could be for a distributed fresh food in a hydroponic farming community, or any kinds of local communities that might be wanting a decentralized exchange, and also accompanied by a community token for how we actually run the economy in our community.
So how are older commerce institutions adopting the blockchain?
You mean, I'm not sure what you mean by older.
Places like Amazon or Walmart.
Yeah. Well, one thing that's been interesting is a lot of the web software retailers, like Overstock and Newegg Software, were some of the first to announce the acceptance of Bitcoin. So Bitcoin you can use it in physical locations in real life, and you can also use it for purchasing economic transactions on the web. And many vendors have moved to this. Also, what's nice is if you are a vendor, it's much cheaper to accept Bitcoin than to accept credit cards. That 3% transaction fee goes away. And BitPay is the merchant Bitcoin transaction provider. They have well over 50% of the market. They're a gold standard. So if you are a vendor, it's very easy to accept Bitcoin, and you would convert it on a daily basis. So there's very limited exchange rate risk. But it's actually quite easy to accept Bitcoin if you are a vendor. And many vendors, it would be just like accepting PayPal or another credit card form of payment. It's very easy conceptually.
How are people using the blockchain to build new file storage and communication applications?
So some of and one of the poster child projects here is called Storj, STORJ, and MadeSafe is another project. And so the issue is exactly as you mentioned earlier. You referred to blockchain bloat, which is already just the transaction volume makes for a big blockchain. And we can't possibly store related data in the blockchain transactions. So there is one memo code, a comment code field in the blockchain transaction. It's called op_return. And it's, I believe, 80 character field. So that's enough to stick in another cryptographic hash of a digital asset confirmation, for example, or any other kind of commenting. But that's definitely not where you would want to store a whole gene or an EMR or any kind of thing. And so in the blockchain ecosystem, we would have secure blockchain records that record data and give the pointer to off-chain secured decentralized storage. And so I can register my genome file on the blockchain with a pointer to its off-chain location via Storj or MadeSafe. And then when I join a project like DNA Bits and I contribute my genome to this health data commons, then I provide them with my key, the private key by which they can access my off-chain stored data. And so in the overall, blockchains are just one piece of the new decentralized safe crypto architecture.
So is there a fair analogy to say that that's sort of like using a URL shortener on Twitter to compress a message into 140 characters?
Quite similar, and then plus the cryptographic protection.
Right, interesting. So let's delve back into engineering just a bit. Let's say you wanted to build a voice over IP application on the blockchain. Mm-hmm. What would that even mean? Like, to build a voice over IP application on the blockchain, does that even make sense?
Yes, and it exists. It's called Ostel, OSTEL.co, and it's basically a decentralized secure version of Skype. And so some governments listen in to Skype, and Ostel.co is exactly the blockchain decentralized secure alternative to that. And of course, it makes sense to have a secure VoIP service.
And so how would, if an application developer wanted to do that, just from an engineering perspective, mm-hmm. how would he go about that? Or he or she?
Yeah. So would we go to the GitHub repos for Bitcoin and the forums and look for the different kinds of parameters already existing in software projects to do the new project. And so there are a number of Bitcoin-related wikis and forums and Stack Exchange discussion areas, and then similarly also for Ethereum. So the point I didn't make about Ethereum previously is that Ethereum is really like a blockchain 2.0. It's for smart contracts. It's for very sophisticated kinds of transactions, as opposed to all of the Bitcoin cryptocurrencies are for much more straightforward currency transfers. It's a spot transaction, a one-time transaction, as opposed to a constellation of events happening in the future, like, for example, a loan. So if you want to do a peer-to-peer decentralized loan, you'd use Ethereum. If you want to just do buy a coffee cash transaction, you'd use Bitcoin. And in the case of Ethereum, there's ether.fund, which is a developer portal with a number of code examples in human-presented format.
Right. So essentially what you're saying is if you want to build a application on Bitcoin or blockchain, the technology is there, the developer resources are there, and I would encourage people to go out and try to do it. So I want to spend the remainder of this discussion talking about the more ambitious, higher level implications of blockchain technology, which you write about a lot. And I'll start by saying, how will the blockchain change government?
Well, an interesting case in point is June legislation in Vermont to look at blockchain public records repositories. So the idea with one core functionality of blockchains is the hashing capability, by which I mean the ability to time date stamp the contents of a digital file at a certain time. And so if you want to provide proof of existence of, say, a particular document, like a will or a contract or a software code base or a digital artwork, what you could do is run a hashing algorithm over it. And that'll, no matter how large the file size, could be a genome file. And what will pop out at the end is a hash, a 32 or so character code that corresponds to the exact contents of that file at that time. And then with that hash in the memo field, you can do a blockchain transaction, which will be timestamped. So that confirms that file's contents at a very specific time and date. And then later, it's not at all that the world can access that file, but the hash of that file is publicly accessible. And then what happens in 50 years when you need to proof of existence your will, for example, the same hashing algorithm is run over the file. And if the file has not changed, then the same hash will be generated. And so this is really the way that we can move all of a society's public records repository into a blockchain format. So that's the first and most important way of blockchains and future governance, that all documents might be handled via blockchains. And that could be title registrations for houses and autos, for property transfers and registrations, for marriage licenses, for death certificates, for business registrations, for all manner of public documents that need to be recorded.
You have some incredible resources on blockchainstudies.org, and I will include those in the show notes. To give listeners an idea of how deep your thinking is, there's a slide share called Blockchain Health and Crypto Wellness Futures. What is at the intersection of health and the blockchain?
So to me, blockchain technology is a way we get to truly this next node in global scale computing. Blockchains are a general computational substrate, and they really get us into the big data era. We've had centralized models. Google's 10 million servers that continuously crawl the web are what we think of as big computing now, but that's tiny compared to what blockchains could do. And the first application area for really big data is health. And that includes EMRs having a universal structure worldwide for how we preserve electronic medical records, preserve and access, and then also all of the health data research that we need to do with the full whole human genome files, the metabolome, the microbiome, human health history. All of these big data health streams can't be really evaluated for thousands of people in a centralized format. And so we need to do that in a decentralized model, and blockchains are finally a way that we can do these health data research commons. And then I also think of some of the more exciting exotic properties of blockchains like demurrage. You asked about demurrage currencies, and a demurrage currency is a currency that's redistributable. And so what that means is that we could implement general guaranteed basic income initiatives with a blockchain crypto coin, and that could provide the sustainability allowance in abundance economies. That's a guaranteed basic income initiative, but also demurrage currency. So demurrage currency is a redistributable currency. So what if we started to think of other resources as currencies, and do redistribution with them? So for example, the human brain, the way that new ideas happen and coordinated function in general is through long-term potentiation. And so this is synapses signaling to each other. And cognitive enhancement drugs like Siltep are specifically targeted at stimulating long-term potentiation. And so what if we thought about potentiation as a redistributable or demurrage currency in the brain, and we started using principles we're learning from blockchains in the way we manage other situations like facilitating ideas that we have in our brains. And also, and this is relative to human brains, but also as we're building artificial intelligence, machine intelligence, how we might have the creativity and ideation possibilities that we have with human brains, how we might stimulate that in a computing network in an artificial intelligence kind of way. And I suggest that we can draw upon blockchain principles to do that as well.
So again, I really love the crispness that you have defined all these different ideas. So one of the things I want to talk about that you mentioned is basic income. Do you believe that basic income is a necessity for us to have a functioning economy going forward?
I think that basic income initiatives are where we are moving to in the future. Not necessarily a necessity, but an idea that whose time is starting to come. And so this is the idea of just supplying the basic. We're so rich as economies, and especially with the automation economy, that we're starting to get to a point in different countries at different times, but we're starting to get to the point where we have the resources available to pay every citizen, every person, monthly, weekly allowance to cover basic sustainability, basic food and shelter. And what would it mean if all of a sudden economics became something of abundance and not scarcity, where everybody's minimal needs were met, and then selecting different kinds of work or productive activity could be on the basis not of necessity, but on the basis of interested, willing participation. And this to me is part of an overall shift from scarcity to, this is what a mind shift from scarcity to abundance means. It means there's a blanket of needs met, so that higher level human endeavors can be focused on.
So that's awesome. So we could spend so much time on that, if readers want to know more about some of the stuff behind what Melanie is talking about, I suggest checking out the stuff by Martin Ford or by Tyler Cowen or Ray Kurzweil if you're feeling more optimistic. So how would you define the singularity?
Well, there are a number of things. What people generally mean by the technological singularity is a moment when computational intelligence exceeds human intelligence. However, I think a more helpful frame, and you just mentioned Tyler Cowen and some of these other authors, Luciano Floridi is a philosopher of information at Oxford, and what a number of these analysts, economists, and philosophers have been pointing out is that already it's not a case of humans versus machines. Already humans and machines are in considerable interaction and collaboration. And so already a person interacts more with technological entities than with other humans. And the best agent for the job is a computer doing 95% of the routine tasks and a human doing 5% of the innovation or exception tasks. And so we're already in a world where we're inextricably collaborating with machines. And so to me, blockchains, another benefit of blockchains is that they're a structure where we can preserve the safety and integrity of different kinds of agents, meaning human and machine agents, so that machine agents don't take over humans, but humans retain integrity and identity in an overall system of collaboration with checks and balances and trust and security. And this is another benefit of blockchains being the format for longer-term human-machine collaboration. And so I think the thinking has already gone beyond the singularity to a reframe of how can we humans and machines work together in positive collaboration, positive and safe collaborative environments.
So would you say that the blockchain is potentially a solution to the artificial intelligence problems raised by Elon Musk and Stephen Hawking?
Yes, definitely. And I have a whole chunk of work on how blockchains can be used to enact friendly AI. Because what we didn't realize, we always thought we'd have super intelligent computers, but we didn't really consider the world, which is one of smart networks, where all of relevant and important transactions occur on networks. We want to access resources, information, conduct transactions, go about our business. Any agent wants to go about their business, and to do that, it will be in a digital smart network environment. And to conduct transactions, they will need to be validated and confirmed in some sort of consensus mechanism. And that is where, you need to be a bona fide good agent with a reputation and good reputational standing to have your network transactions confirmed, validated, and executed. And so this is how friendly AI can be enacted, that even an AI that would like to be malicious has to behave as a friendly agent to accomplish even the most basic of network operations. And so blockchains are a way of enforcing good player behavior. And that's something we already see, for example, in the mining operation, that and the bigger question of secure distributed network computing more generally is how do we evoke a truth state and a world which is based on good player behavior.
You spend a lot of time thinking about the future. I'd like you to give me the most ambitious yet believable extrapolation of the present to the future that you have imagined.
Is
it something like the gray goop, or like we're in space stations, or what does it look like to you?
Yeah, well, I think one of the topics I work on as a technology philosopher is personal identity. And I think that as humans, we're sort of overly attached to the notion of personal identity. Right now, we're packaged in this form of a physical body, but that could be an evolutionary convenience. And I think when we look at the future, everything seems to expand. There are more ways to do things. So, for example, records didn't ruin the radio industry. It actually expanded the music appreciation. And now we have cloud sound and all kinds of different modes of participating in music generation and listening. Similarly with intelligence. And so one of my future visions is that we start to have more and more digital copies of ourselves running on blockchains or other digital environments. And already you could impute from with a deep learning algorithm some sort of reasonable fidelity for a current person or current person from their web imprint in the case of lots of people. And so I think that identity becomes malleable, and I think that, and it becomes multiple. And so we become less and less wedded to this personal, this physical form that we have found ourselves in. So I see identity multiplicity as a future thing. One current paper I've been working on is in a blockchain, using blockchains as a safe way to participate in a cloud mind collaboration. So what we're really wanting is mentally to collaborate in a bigger fashion and solve problems, contribute, arrive at new ideas beyond that which we might be able to do in our own mind alone. And what if we could do human-machine, blockchain, cloud mind participations in a safe way? So that's a flavor of some of the more esoteric or far-reaching things I'm thinking about.
What is the Institute for Blockchain Studies?
The Institute for Blockchain Studies is a nonprofit research startup that I founded last year, specifically to look at the impact of blockchain technology on society.
Great. So I'd like to scale back a bit, and if somebody in the audience is somebody that is looking at the things that you just defined, the ambitious cloud mind, sort of collaborative, almost like post-religious philosophy, and this person is looking at the current state of technology, looking at Ethereum and blockchain and Bitcoin, what are some ways that person can help to work towards the future that you defined so positively and so eloquently?
Yeah, I would say go to ether.fund, get a code swatch of Ethereum smart contract code, start making an application for any area of relevance and interest to individual people. Like, for example, I have a sick grandmother and I want to have a blockchain smart contract advocate to take care of her legal advocacy on her behalf in a health situation. And so that's something that can already be done right now, a smart contract AI advocate for somebody in a blockchain. And so there are right now is the time to start developing these applications, and it's already possible to do so.
And do you have any meta advice for people that are working on their career right now? So it strikes me that you seem to be in a position that you're pretty happy with the work that you're doing. But your career has been really interesting. Maybe you've enjoyed it all the way through, but there's been all sorts of different things in your past. Do you have any suggestions for how people can navigate their career from between different waters where they may have varying degrees of satisfaction in their job?
And that includes making an investment in a less satisfactory area, perhaps to get the learning or the benefit or of that. Yeah, I think my recommendation would be just get into very close touch with purpose. Like, what's your purpose for doing any one thing? And to be quite clear with yourself that, okay, it's good, it's fulfilling these needs, it's not fulfilling these other needs. I'm going to do this for a time frame. I'm going to try to explore other things. So I think staying on touch with purpose is useful, and then being willing to leave situations that don't work, and really be extremely enterprising in creating and realizing. What I've actually realized is I don't usually run across happy career situations for myself presented in the world, and so I have to create them. And so it's just a matter of taking the responsibility to create situations that do work for me. And I expect that could be true of innovators and entrepreneurs. And so just a willingness to define what you want and try to create it.
That's fantastic. Melanie Swan, thank you for coming on Software Engineering Daily. It's been a real pleasure talking to you. You were really fantastic at just articulating the both the low-level aspects of Bitcoin and blockchain and all the related technologies, as well as the most ambitious societal implications of this technology. And in doing that, you've really fulfilled the mission of what this podcast is all about. So thank you so much.
Thank you very much, Jeff. I really enjoyed speaking with you today.